Let R be a relation on Z cross Z defined by A comma B related to C comma D. Means R is a relation given which is defined on Z cross Z, that is A to Z cross Z to Z cross Z. Say this is A, where Z is integers. So in Z cross Z contains ordered pairs A comma B, let us take, and it is related to the other ordered pair C comma D. So it is given R is equal to A comma B is related to C comma D such that AD minus BC is divisible by 5. Divisible by 5 means it should be divided with 5. So 5 into some constant k, where k is some integer. So we need to check this R is reflexive, symmetric or transitive. So reflexive, the definition of reflexive, for every element in the set A comma A must belongs to the R. So for every element in this set A comma B must be related with A comma B. So let us assume or consider A comma B belongs to Z cross Z such that A comma B is related to A comma B. So which implies AB minus AD minus BC. So here A into B minus B into A. We can write AB minus BA, that is AB minus AB, which is equal to 0, is always divisible by, we can say is always divisible by 5. Hence we can conclude that the relation R is reflexive, because for every element A comma B, A comma B is related to A comma B because it is divisible by 0. Now for symmetric, coming to symmetric, symmetric definition says that if here in this case, if A comma B is related to C comma D, then C comma D must be related to A comma B. Basically the definition is, if A is related to B, then B must be related to A. So here in this case A comma B is related to C comma D, then we have to prove that C comma D must be related to A comma B. So let us consider A comma B is related to C comma D. So as per the definition, AD minus BC must be divisible by 5. That is AD minus BC is equal to some 5 into some constant k. So which implies we can also write BC minus AD is also equals to some negative 5 times of k. That is BC minus AD is equal to 5 into some negative constant, which we can say that BC minus AD is also divisible by 5. So we can also write this as C comma D is related to A comma B, so that CB minus AD, we can write CB minus AD is equal to 5 into some constant k. So C, for A comma B related to C comma D, we got C comma D is related to A comma B, and hence we can say that the relation R is symmetric. And now coming to transitive, transitive definition says that if A comma B, B comma C belongs to R, then A comma C must belongs to the relation R, and hence we can say the relation is transitive. So here let us consider, let us take an example because this is not transitive. We need to give one counter example. Let 4 comma 1 is related to 15 comma 5. So which implies that, so 4 5s are 20 minus 1 15s are 15. So 20 minus 15 is 5 is divisible by 5. So we can consider 4 comma 1 is related to 15 comma 5. And now let us take the second ordered pair. 15 comma 5 is related to 1 comma 1. So here we can say 15 ones are 15 minus 5 ones are 5. So 15 minus 5 is 10. Again it is divisible by 5. So we can say that 4 comma 1 related to 15 comma 5 and 15 comma 5 is related to 1 comma 1. Now we need to check that A and C. So let us consider here 4 comma 1 and 1 comma 1. So consider 4 comma 1 related to 1 comma 1. So which implies here 4 into 1, 4 minus 1 into 1 is 1. 4 minus 3, 4 minus 1 is 3, which is not divisible by, which is not divisible by 5. And hence we can say that for A is related to B and B is related to C, but A is not related to C. So here we can say 4 comma 5, sorry 4 comma 1 is not related to 1 comma 1. And hence we can say that the relation R is not transitive. So this relation is reflexive and symmetric but not transitive. So we can go with an option reflexive and symmetric but not transitive, second option.